All right. So hey everybody. Feel free to keep your videos on. I love to see faces when I'm teaching. Somehow that sort of visual feedback is helpful. I love seeing those like confused faces and also those light bulb moments. If you're comfortable, feel free to leave your video on. Please do stay muted unless you have a question. We're not a very big group, so if you have a question, please feel free to unmute and interrupt me. Your questions are invaluable, and certainly there might be things that I don't think need an explanation, but do need an explanation, so definitely interject. Um, I mentioned that I am going to bounce back and forth between GeoGebra Classic 5, GeoGebra 6, and the web version, just to kind of show you sort of some of the differences and how you get to the same things in the different versions. Um, because I know not everyone is necessarily using the same version, and that's okay. Everything that we do today can be done in any version. And I say GeoGebra. Some people say GeoGebra. I think that actually the company actually recently did like a social media like, how do you pronounce? And and then apparently there's a lot of different ways to say it, and they are all acceptable. So um, I don't Geo, I don't know, whatever. I call it GeoGebra. So, without further ado, I am going to just share my whole screen. So, apologies for all of the million and one things that I have open, but because I'm going to be bouncing around in different things, it's just easier for me to share my screen. So, all right, so I decided that I'm going to do a fairly simple pattern construction, um, just so that we can fully appreciate some of the GeoGebra tools themselves. And then obviously you can apply these things to more complicated patterns. And I'm going to try to do these at least once a month. And so I'll do, some more complicated constructions moving forward. But for today, I wanted to look at, oop, I meant to go back. I want to look at this family of patterns. So hopefully we agree that these two patterns are related. So let's see, the one on the left is from India and the one on the right is from Morocco. But we're looking at six-pointed stars surrounded by hexagons. And on the left, we have regular hexagons, and on the right, they're at a slight angle. But it turns out that these two patterns are built on the exact same underlying geometric grid. And in fact, they're just two members of an infinite family of patterns that we can easily construct in GeoGebra. And I know that a lot of you really like the animations that I've been showing lately. And so hopefully um, you'll enjoy the little bit of an animation that I'm going to show you how to make today. So if I want to construct a pattern, the first thing that I look at as both an artist and a mathematician is the minimal repeat unit of a pattern. And for most of the Islamic geometric patterns, that's a minimal triangle. It's not always going to be a triangle. Sometimes you have a rhombus or a rectangle that's the minimum repeat unit, but very often it's a minimal triangle. And so let's just kind of take a look at these patterns. Usually, the kind of the easiest way to locate the minimal triangle is to ask yourself, where do mirror lines intersect in a pattern, or where do I have points of rotational symmetry that are not the result of a mirror reflection? So these patterns, while certainly we have rotational symmetry, it can be explained by mirror reflection symmetry. So we don't really have to worry about rotations here. But would we all agree that at the center of a star, a center of one of the six-pointed stars, we have some mirror lines that would intersect? I could fold this pattern in half through lines that go through the center of that six-pointed star. Then we also have symmetry where two of the little petals come together, right? I've got two mirror lines that come together there. And it's not enough just to have a twofold mirror symmetry, and this is going to be a sixfold mirror symmetry through the center of the six-pointed star. Somewhere we also have to have another symmetry in there. So if we look at the middle of either one of the hexagons, the regular hexagons or the sort of squished hexagons that I have a hard time calling a squished hexagon a hexagon, even though it's totally a hexagon. One of the irregular hexagons on the right, we've got three mirror lines that pass through the center there. So those 3 points are making up our minimal triangle, and I have those highlighted here. So that little triangle made up of a point at the center of a star, a point at the center of the hexagon, and the point where two hexagons come together. If we construct that, then we get the whole pattern. And that kind of goes in general for any pattern. If you can find that minimal triangle, construct it, you can easily generate the rest of the pattern. And what's cool about this family patterns is look at what's inside that triangle. It's just a single line segment, like just one little line segment with a vertex at the right angle where the two hexagons meet, and then somewhere along the hypotenuse of that triangle, the line segment ends. So if we can find that little line segment, all we have to do is reflect it around and we get our pattern. Okay, so that's going to be our goal, right? Is let's construct this little guy and then we'll generate it. So then let's go ahead and move over to GeoGebra. So hopefully, ultimately, something like this is what we're going to end up with. Let me just turn the animation on. So hopefully something like this is what we're going to end up with today. And I hope that that's not lagging too bad for you. But in order to do that, this is kind of where we want to start. And this shows I have every single thing, almost, except for this one little polyline, which I could show it, but whatever. This is sort of almost a minimal construction for that pattern. And I want to just kind of go ahead and show you this so you can get a feel for how that minimal triangle, which I have highlighted in yellow, controls the rest of this pattern. So kind of just let you take a look at that for a little bit. So I would say notice especially the blue line that's sweeping out that angle, okay? This slider that I turned the animation on is a variable that's holding a value that determines this angle, okay? And it's that angle that's changing. And if I can find this line and that minimal triangle, everything else is reflected, just like a kaleidoscope, right? I've had a lot of people say your patterns and your animations remind me of kaleidoscopes. Well, that's because that's they're doing the same thing. They're just reflecting things over and over again. All right. So let's build this guy from scratch. So let me make sure I've got this saved. Oh my gosh, GeoGebra has like no, sorry. Zoom has this new like apps bar that, oh, I can close it. That just popped up and I was like, how do I get rid of this thing? So let me save. Somehow being able to see you guys and my software at the same time is challenging. All right. So I'm in Classic 6. And hopefully yours looks like this. But if it doesn't, so when I do File New, I have this menu over here. And we could use the graphing version, but it has more tools than we need. So I like using the geometry one. And to start off, usually it's just sort of a blank slate, but that's not going to be quite enough for us because we want to define things like super precisely and we want to be able to type in inputs and algorithms and all kinds of stuff. So I want to be able to view my algebra view. Um, and so let's see. Um, if I, I don't know where anything is in GeoGebra 6. I hardly ever use it. Let's see, view, there we go. Okay, so the hamburger menu at the top one, under view, we want graphics showing and algebra showing. If I'm in Classic 5, and I open a new file, I like to have my algebra graphics and properties showing, and there's a nice view menu at the top where I can have those things showing. If I'm in Classic 5, I typically don't like to see the axes and the grid, although they have their purposes. So I want to first thing I'm going to do is I'm going to save my file. I'm going to give it a name because oftentimes I forget to save things until I get way too far and GeoGebra freezes up because I've put too many things in there and then, oh, I've lost so much work. All right, so we've got this. And why is my right clicking not working? Lovely. Oh, there we go. So if I right click inside the graphics view, I can hide my axes and my grid. Another way I can do that is if in the preferences under axis, I can show the axis, show or hide the y-axis, and under grid, I can show or hide the grid. So kind of similar with GeoGebra 5. I could show those things if I wanted to, but like I can have all kinds of fun grids if I want to. Which in the isometric grid obviously has its place. We could totally cheat and like build this thing right on an isometric grid, but I'm going to show you guys how to do it from scratch. All right, so the first thing we need are 2 points. And I could just grab my point tool and click twice and get 2 points. Perfectly valid way of doing things. nothing that we do is dependent on specific measurements or scale, or, it doesn't matter what's up, down, left, or right. But I like things to be kind of neat and organized, and I like my horizontal lines to actually be horizontal and my vertical lines to be actually vertical. Um, so if, say, I used my point tool and just clicked twice, what I would want to do is go into the algebra of those variables, and I want to edit point A to be 0, 0, and I want to edit point B to be 1, 0. Now, that's not actually how I personally ever do this. I'm going to hop over here to my GeoGebra 5, and I always type in the input bar. So what I'm going to type in the input bar, I'm just going to keep a little notepad so you guys can see that, is I'm just going to type A equals 0, 0 and hit enter. So I'm going to type exactly that into my input bar and hit enter, and it generates that point. And then same thing for point B. I'm going to type point B equals 1, 0 in parentheses, and I'm going to put that in my input bar, and I'm going to hit enter. Typically, I'll type directly into the input bar, but I want to make sure you guys can see this notepad view. All right, yay, we have 2 points. All right, so mathematically, 2 points define a line. In GeoGebra, 2 points also define the side of a regular polygon. And even though only one version of our pattern has regular hexagons in the final pattern, all of the family of the patterns are built upon a grid of hexagons. So I want to construct a regular hexagon. And what you'll want to do is look for the polygon tool, and under that menu, look for regular polygon. If you are a poor unfortunate soul using the browser version, you're going to have to scroll way down to regular polygon, because you can't just select like one tool and then there's a drop down menu. They're all separate. But we want to look for regular polygon rather than polygon. And if I have my regular polygon tool selected, no, I'm trying to do too many things at once. When you hover over a tool, it tells you kind of how to use that tool. So if ever you're like trying to play around with a new tool and you're not really sure what information you need to give it, the tool tells you what to do. So we're going to select 2 points, then enter the number of vertices. Now, the order in which I select them here isn't that important, because I don't care what orientation my hexagon has, but the order in which you select the points determines the orientation. So the regular polygon is always going to construct itself counterclockwise from the points that you select. So if I select first A, then B, and tell it I want 6 vertices, it's going to go A, B, C, D, E, F counterclockwise. If I selected B, then A, it's going to go clockwise from B and construct a hexagon below my line segment. So we want this hexagon, and I mostly just want that hexagon for the line segments and the vertices. I don't really care about this interior, and in fact, I don't really want that interior to be there, because it's going to kind of just get in the way. So if your properties aren't showing in 5, we can just right click and go to Object Properties. But I want to go to Color and reduce that opacity to 0. So let me go back over here to GeoGebra 6, underneath Polygon, regular polygon, AB, 6 vertices, and then the little gear gives you your settings. Under color, reduce the opacity to 0. Okay. And basically what that does is that my polygon no longer can be selected as a whole just by clicking in the middle of the polygon. If I had that interior colored, I could just click on the inside of it and it would think I'm trying to select the whole polygon. If I want to select the whole polygon now, the way I have to do it is by using my algebra menu. And let me see. Yeah, that's fine. So notice I clicked this icon on my algebra menu. If I click over here, I can change how my objects appear. And I really like to sort them by object type because that way I can just kind of hide the stuff that I'm not really working with, and it's a lot easier to organize things. So I can select that polygon in the algebra view now. I can hide it if I want by clicking on the little dot next to it. Same thing in 5. I can hide it or show it. Here, there's a little sort objects by. Okay. All right, so got my hexagon. Let me look at this pattern again. No, that's, you don't want my resume. Why do I have that open? Boop. So let's take a look at this pattern again. So what we want to construct is the hexagon that this star lives inside. So the hexagon whose vertices are the centers of these hexagons, where I just have this one star that lives in a hexagon, and then I can tile the plane with hexagons, and so I've got a bunch of stars. So that's what this hexagon represents. And I'm using my scroll wheel to zoom in and out. Make that a little bit bigger so you guys aren't just like struggling to look at a tiny hexagon on my screen. All right, so then I want to find the center of my hexagon. And there's a lot of ways we can do this. But because I also want some lines that I'll be able to reflect around, I want to construct some perpendicular bisectors. So I want to construct a line that's perpendicular to line segment AB that passes through the midpoint. And those of us that use a compass and straight edge know this takes quite a few steps, but luckily GeoGebra has a perpendicular bisector tool underneath the perpendicular line tool. So we don't want perpendicular line, we want perpendicular bisector. And if I click on A, then B, I get the line perpendicular to AB that passes through the midpoint. So I'm going to do that for AB, and I'm going to do it for BC. So it's the perpendicular bisector tool. And I'm going to show it again, this time in Classic 6, Classic 5. Not perpendicular line tool, but the perpendicular bisector tool. Here I could click on B then A instead of A then B. It's going to give me the same thing. And B then C. All right, now this is where you've got to be careful. Certainly where two lines intersect, mathematically that defines a point. In GeoGebra, we have to actually define points if we want to be able to use points. And here, I don't just want my point tool. I want my intersect tool. That's important because it's going to tell us this point is defined as the intersection of these two lines. So underneath my point tool, I'm going to grab my intersect tool. And there's a couple of different ways you can use this. So as long as you don't have too much information going on, your cursor should change when you get close to an intersection, and let you just click on that intersection to define a point. If, say, you've got a lot of stuff going on near that intersection, you can always just click on the two things consecutively that you want to find the intersection of, and it'll find it for you that way. I use both methods, just sort of depending on how busy my construction gets. So like to find this intersection on BC, I'm just going to click on it. So let's get the intersections where our perpendicular bisectors are at the midpoints of these two sides and that center point where those two lines intersect. So I'm going to do it in both constructions. So underneath my point tool, intersect, I want this one, and this one. All right, so we're almost there. Our minimal triangle is going to be this guy. So in here it's AG, triangle AGI. Over here it's AGH. So the names of the variables aren't really important until you start defining things like with code where you're referring to certain things by name. And in that case, like we're all going to have different variable names. So you'll just have to pay attention to what, mostly this center point. We'll use that one a lot. All right, so I want to construct a few more lines here. So I think for our purposes, it's going to be easiest if we construct our final perpendicular bisector that goes through the other two sides. So you could either construct that on CD or on AF using your perpendicular bisector tool. So perpendicular bisector tool, this time I'll do CD. So that gives me lines through the midpoints of each of my sides. And then I also want lines going through each of my vertices. So in my construction, I didn't do all of this, but I think especially kind of if we're beginners, it'll help us to see all these mirror lines. And it won't be too clunky, I promise. We're not going to do too much more than this. So those are sort of the radial lines that you would generally start a compass and straight edge construction with. We're mostly going to use those when we start reflecting our minimal triangle around. All right, cool. So I've got my triangle here. What are we missing? We're missing that line segment. So remember we, let's see, I think, yeah, I uploaded it here. And I'll share a link to this construction both on the Eventbrite page for this class and the Patreon, so that you have a couple different GeoGebra files to play around with. But remember, we said that that line segment is defined by this angle that that blue line makes, okay? So I'm defining this as the angle between line GH and whatever variable that point is, doesn't matter, and this blue line. But I can't really define this line until I have my angle defined. So what we're going to do next is we're going to define an angle using a slider. So in my menu, I want to find slider. And then you can click anywhere. I would find it like a open space in your construction and click. And then the slider is going to prompt you for a few different things. It's going to say, are you trying to define a number, an angle, or an integer? And you can define different properties. We're using our slider to define an angle. And really the main significance here, but like having that difference between the variable holding a number and an angle, is that the default setting inserts the degree symbol for you. So make sure you don't delete your degree symbol. But we want our angle to vary between 0 degrees as a minimum and 90 degrees as a maximum. And I like to increment it by half a degree. So I'm doing 0.5 degrees. If you accidentally delete your degree symbol, you can always hit cancel and redo it. We don't have to worry about slider or animation right now. So I'm just creating an angle alpha. Doesn't matter what its starting value is, but minimum 0, max 90, increment 0.5. And right now, all this does is move. It doesn't control anything. So it's just holding an angle variable. So I'm going to show that again, this time in Classic 5. So slider, I'm going to click. It looks a little bit different here, but I want an angle. I could give it any variable name I want to. We typically use Greek letters to represent angles in mathematics, so alpha is a good symbol for that. 0, I want to change 360 to 90, and I'm going to change my 1 to 0.5. All right, cool. So now I have this variable that holds a number that represents an angle. Well, we have to be able to use that angle. So let's take a look at what this angle is defining. It's defining, or we want it to define, a rotation away from the vertical. So when my angle's at 0, I have a vertical line. And when my angle is at 90, I have a horizontal line. And so what I'm going to do is I want to take a point, not at, in this case, G. I'm going to use H. And I want to rotate H by this angle about point G. So that's what it would be according to the variables that I have here. Here I have point G again, and I have point I. So I want to rotate So actually, let me go ahead and type this in here. So if I type rotate in GeoGebra and open, oh, well, this version didn't prompt me. There we go. So if I start to type rotate, it will show me like some of the possible inputs that I can put into that function. So rotate is a GeoGebra function. So I can input an object, an angle, and a point, etc. We're going to use the second option where we pick an object that we want to rotate, comma, the angle about which we want to rotate, comma, and the point about which we want to rotate. So we want to rotate point I by angle alpha about point G. And let me go ahead and just type it in here. So I want to rotate, and I'm going to open parentheses, capital I, uppercase and lowercase matter, and then I'm going to type a comma. And I don't have a Greek alphabet keyboard, so I can't just type alpha. But there's a little keyboard icon down here. And, oh, see, do you have is there a question? Just how far do you need me to go back? I don't have a note sheet. I will after the fact, because there's so many different ways you can construct this. So I certainly don't mind repeating something. Okay. Well, you'll always have access to the recording afterward. All right, so where was I? So we want to take this point I and rotate it by some amount alpha about point G. So I'm going to type rotate I, and then I lost my little keyboard tool. There we go. So if you don't see the, like, click on ABC, and then there's the Greek letters that you can swap on and off. So I'm going to rotate, oh, I want that inside my parentheses. So I'm going to rotate point I by alpha about G. So this is, I'm going to copy that. And that's what I'm going to type into my input bar and hit enter. And now we can see that when I move my slider, it actually does something. So I'm going to show that again in Classic 6. So here, my center point is H. So I'm going to rotate H by alpha about G. So in my input bar, this time down at the bottom, I'm going to type rotate. And here, like, again, it sort of pops up the different options. I could even click this and then replace the first object with the thing I want to rotate. So I want to rotate H. In order to do alpha, there's a symbol button at the far right-hand side of the input bar that lets you pick special characters. And then I'm rotating again about point G. And again, now my slider actually does something. So I'm going to pause there because we've kind of got to make sure we have that part down before we can move forward. So if there's any questions, anybody needs me to show any parts of that again, let me know, because we can't really move forward without that. Is everybody good? Jeannie, you got a question? All right, so hopefully, if you've got, if you have questions, when you go back and watch the video, it'll make more sense. Yeah, so you need that alpha. I wonder, so sometimes like GeoGebra will let you just type the names of things. So I wonder if I just typed rotate H by alpha about G, if that would, no. Yeah, so you have to actually use the symbol. I can type pi for pi, but I guess I can't type alpha. So yeah, we have to use that special character alpha in order for it to work because our variable is alpha. Now certainly you could rename, like if it's annoying to have to use a Greek letter here, like you could totally change this to X or whatever. But as a default, GeoGebra is going to assign capital letters to points, lowercase letters to lines, line segments, and conic sections, and Greek letters to angles. So while you can name things kind of whatever you want, you know, there are defaults. Okay, so I've got the point that I want, and now I'm going to define a line. Oh, I never put in my other lines over here. So let me put these lines in. Hopefully you put your lines in connecting your vertices. I never did. I did it on the other version, but not this one. So I've got my minimal triangle here. 2 points define a line. So I'm going to select my line tool and I just need to tell it what 2 points I want to draw a line through. So I want to draw a line from this midpoint, G, to H prime, so that rotated point. And I like kind of this line to be blue. That's sort of my default kind of color for these generating lines. So in GeoGebra 5, I can do that, right click, object properties, click on color. In GeoGebra 6, I'm gonna have to hide you guys for a second because I can't see what I'm doing. In GeoGebra 6, I click on my 2 points and I can just change the color from here, which is kind of cool. But you can also change the color in the more complicated menu. So that is kind of one nice thing about GeoGebra 6 is the ability to do some kind of common like line weight and color things there. So now when we move our slider, it does more things. Woo! And if I take my intersection tool and find where that line intersects this radial line, we can see that that point moves along the hypotenuse between vertex A and the center of the hexagon. And that, my friends, is the line segment that makes up the pattern in our minimal triangle. So if we can get that, the rest of this is going to be a breeze. So let me do it over here in 5. So I've got my angle, I've got my line, I'm going to grab my intersect tool, and I've got my line segment. So let me pull up again what we're kind of trying to get to. So we've got this. Do we see how every other sort of point in this star is really just a reflection of this point around or this point around? Okay, so if we can see that, then sort of everything else is going to fall into place. So for the sake of like not constructing too many things, as a general rule, I prefer to reflect points when I'm trying to construct things rather than reflecting like whole polygons or line segments, just because I don't like having to construct more than I need to. I mean, we've already constructed a little bit more than we need to, but that's okay. So that I don't get confused, I'm going to hide this point I prime because it's not a point in my pattern. So I can either click on the circle next to it in my algebra view, or over here in the basic, I can uncheck the show object box. There's a number of different ways that I can hide that. If I'm in 5, I right click and click show object and it goes away. Or, I can do the same thing over here. Just click on the little circle. All right, so what I want to do is construct the hexagon that lives, the 12-sided polygon, so the star hexagon, or the 6-pointed star that lives inside this hexagon. So I want to find the reflection of this point along each of my lines to a vertex, so my radial lines, and I want to find the midpoints of each of those sides. Well, that part's easy. I just need my intersect tool. So I've already got 2 of those defined. Let's go ahead and define the other ones with the intersect tool. And if you don't already have those perpendicular bisectors defined, honestly, it's fine. We also have a midpoint tool that you could use instead. So like, let me delete point N. So yes, that's the intersection of those 2 things, but it also happens to be the midpoint between C and D. And so that's another way you could construct that point. For our purposes here, it doesn't really matter how we're constructing it. If, say, this line segment were changing or this line were changing, and you wanted to make sure that point stayed at the intersection despite changes in those 2 things, then you wouldn't want to use the midpoint tool. But here, neither of those 2 things are ever changing. The only thing that's changing for us is that angle. All right, so now I'm going to go over here to my Reflect About Line tool. So it's a line with red point and a blue point. And I'm going to very carefully reflect this point around to make 5 copies of it. So I'm going to click on that point, and then I want to click on the line that I want to reflect that point over. So I'm going to start by clicking on my vertical line. And so we should see point J and point J prime along those radials. I could reflect this blue line around, but I don't really need copies of that line. I really only need copies of this point. So I could now click on either of those 2 points. So I could click on this point to go over here, this point to go over here. I like to just kind of click on one to get to the next one. So I'm going to click on this point, and I want to reflect it over this line to get a point that lands here. If you accidentally click on the wrong line, you can always grab your arrow tool and select a point and just hit delete on your keyboard. If I were to delete point J, that would affect anything that's dependent on that point. So we've got to be careful in that sense. But anything that's independent should be fine. So I'm reflecting this point over this line, then I'm going to click on this point, reflect it over this line, this point, reflect over that vertical, and this point, reflect it over here. And just to kind of make sure all those points are correct, I'm going to move my slider around, and I see that those points move from the vertices of my hexagon to the center. So that's kind of fun already. I'm going to do that one more time in GeoGebra 6. So I'm going to grab my Reflect About Line tool. I'm going to reflect this point over this line, 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 this point over this line. And cool, they work just like they're supposed to. Oh, except I never defined all my midpoints here. So let me get those in there. All right, so if we have all of our midpoints and we have all 6 of these interior points, then we have enough information to construct our star. So we've used the regular polygon tool. This time we're just going to use the polygon tool. And so what we're going to do is we're going to select the points in order that define our star, and then we'll end by selecting the first point again. So let me kind of show you over here what that's going to look like. So I'm going to click this point, then this point, then this one, then this one, then this one, this one, this one, this one, this one, bump, 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 bump. So it's like I'm tracing connect the dots kind of to define that star polygon. And every once in a while you're trying to do this and you realize that you forgot to actually define one of those points before you start to draw your polygon, especially if it's a complicated polygon with a lot of vertices. If that's the case, you just finish it off, click back on the first point, delete it, or click undo, define the vertex that you were missing, and start over. So no big deal, but it is a good way to, your errors do quickly become evident if you forget a vertex, which I very often do. All right, so polygon tool, I'm going to start with point G. And I could go clockwise or counterclockwise here. It doesn't matter. So I'm going to go G, J prime, H, J double prime, L, J triple prime, M, K, N, K prime, O, J, and then back to G. And when I move my slider, I have this fun little star. So let me do it again over here. So I'm grabbing not regular polygon, just polygon. So G, J prime, I, J double prime, N, J triple prime, M, O, L, O prime, K, J, G. Sometimes I find when I have like a very complicated GeoGebra construction that it can be hard to click on the vertices that I want as opposed to neighboring vertices. You can also use the input bar to define a polygon. So you can type polygon, open parentheses, and then just a comma separated list of all the vertices that you want to connect in order. And that's definitely helpful if you have a really complicated construction where you have vertices defined that are really close together and GeoGebra is acting up because you have way too much stuff constructed on your screen and it's like, OMG, what are you asking me to do? But if you type it in the input bar, it's like, oh, okay, thank you. I know exactly what you want me to do. Whereas sometimes clicking doesn't always get the job done. All right, so did we get our star? Do we have a moving star? See, that's fun already, right? And then I can right click and turn the animation on. And that's fun. And another fun thing is, let's see, if let's see, what, I was gonna do a trace, but no, I think that's probably enough. If I want to turn animation on over here, I can't just right click. I have to, what do I have to do? Oh, let's show trace over here, and then turn the animation on. Just you wait. So I'm going to I turned on trace on this polygon, and now I'm going to click on my slider. I'm going to click on the animation. Ooh, maybe it's not as cool as I thought it was going to be. Probably because I have my angle iterated too many times. If I, oh gosh. Come back. Okay, let me turn this trace off. If I were to change this slider to increment, let's say like every 2 degrees or something, the trace might be a little bit more fun. Like, I don't know, it does like a neat kind of, I don't know, you can kind of get an idea of what it's doing, but I don't know, I just think it's fun. But we'll turn that off because it's
Sarah, was that only in version 6?
No, it's in either version. But I'm not sure why. Oh, there we go. So for some reason, it wasn't showing up as an option. But if I'm right click in 5, you can turn the trace on. It just wasn't showing up for some reason. I don't know. I might have been clicking on the wrong thing. But yeah, you can turn on trace for a point. Like I could trace this line if I wanted to, and then when I move my slider, the line does a thing. I don't want the trace on anymore. Go away. Why is the trace still on? Usually it just disappears, so that's lovely. Why did I do that? This is when we save and close it and then open it back up. It's when GeoGebra, sometimes GeoGebra is a little special. It's all right. There we go. All right, so we don't just want a single star, right? We want multiple stars. So what I'm going to do to start is I'm going to make one reflection of this polygon, and then I'm going to rotate that reflected polygon around the center. So for instance, I'll get just this one star, and then from that star, I'll make a sequence of stars around it. So let's do that. I'm going to draw a line CD. It could be line AB, it could be line BC, DE, EF, or AF. So any of the lines that correspond to a side of the hexagon. And I'm going to grab my Reflect About Line tool. And then I want to select the polygon and then that line. I've got to be careful if when I click on the polygon, I accidentally click on a line or a point. Obviously, that's not going to accomplish what we're trying to accomplish. But we can always select the thing we want in the algebra menu. So I could, for example, click on my Reflect About Line tool, select the polygon here, and then in theory that was supposed to work, but it didn't. Let me try that again. So I should be able to select the polygon here and then the line. Why? Oh, see, I don't know. I don't know GeoGebra 6 as well as GeoGebra 5. Anyway, the easiest way to do this is just to click on the polygon itself and then the line. I promise the other thing works. It just wasn't working for me at the moment. In GeoGebra 5, it's real easy to just click on the polygon and then reflect. So here I didn't draw the line, I just reflected over the line segment. Accomplishes the exact same thing. But again, you know, let's move our slider to ensure everything's working exactly how we want it to. Okay, so we've already used the input bar to define a rotation. Now we're going to use the input bar to define a sequence. And I want to rotate this star a certain number of times by a certain angle about this point H. And I already know how many of those I want to rotate by, right? Because there's 6 of them surrounding the center one. So I want to rotate 6 times about point H by an angle. And we have 2 different ways we can think about the angle. We could think about the angle in degrees. So if we know that there's 360 degrees around a circle, 360 divided by 6, 60 degrees. So I'm going to rotate by increments of 60 degrees about point H. Now, I'm kind of lazy and I don't like to have to enter the degree symbol over and over and over again. So I prefer to work in radians. So quick little algebra interlude here, or math. I used to teach this in trig class. So quick and dirty introduction to radians. So hopefully everybody remembers from middle school, probably is the first time you learn this, that the circumference of a circle is 2 pi times the radius. If you don't remember, there's your refresher. So if I know that the circumference of a circle is 2 pi times the radius, if my radius is 1, then the length of the circumference of the circle is 2 pi, okay? And hopefully most of us have heard of pi as an irrational number that's approximately 3.14, okay? I know pi to way too many decimal places. Like, nobody needs to know that many decimal places of pi. I've been actively trying to forget them, honestly. If you remember that it's a little bit more than 3, you're good. So 2 pi, or the circumference of the circle, is a little bit more than 6. A little bit more than 6 and a quarter, actually, right? So 6.28. We could approximate any multiple of pi, okay? So pi is just a number, right? It's a number a little bit bigger than 3, and the circumference of a circle whose radius is 1 inch would be about 6.28 inches, okay? So the units you're measuring in are whatever units you're measuring your radius in. All right, so that's pi. Now, basically, what we want to think about is we're dividing up the circle. We're dividing up the circumference of the circle. So when we talk about measurements along the circle, we're always going to go counterclockwise. So if I go 1 full counterclockwise rotation around the circle, I've gone 2 pi around, okay? So half of the circle is pi, whole circle is 2 pi. A quarter of the circle is half of pi. If I go a quarter of the circle clockwise, I'm at negative pi over 2, okay? So I'm really just thinking about fractions of 2 pi or fractions of half of a circle being pi, okay? So that being said, We don't need that. So what actually is a radian? So if I'm starting at 0 and I sweep out an angle where that angle is exactly the same measure, or excuse me, where the arc along the circumference is exactly the same measure as the radius. So if those have exactly the same length, so in this picture, if S and R have the same length, then we call that angle 1 radian. And regardless of whether R and S are 1 inch or 50 meters or, you know, 10,000 kilometers, that angle is always going to be the same, because as long as that arc length and the radius are the same, that angle will be approximately 57.3 degrees. Okay, so 1 radian, about 57.3 degrees. Well, 57.3 degrees is a weird number. Nobody memorizes that. What's easier is to remember that, well, the circumference has 2 pi, but there's also 360 degrees in a circle. So 2 pi radians is 360 degrees, or half the circle is pi radians, half the circle is 180 degrees. Okay. And the reason that I really like to work in radians more than anything else is because it's independent of units, right? I said it works whether you've got 1 inch, 50 miles, whatever those length units you're working in, we've got radians. And cool thing about GeoGebra is I don't have to use the pi symbol. I can just type pi and it knows exactly what I'm talking about. Okay, so we're going to use divisions of 2 pi to define our angles. So there's the quick little little math review there. All right, so if I want to rotate this polygon by sixths of a circle, okay, well, 60 degrees, but what is that in radians? It's 2 pi divided by 6, which is the same as pi over 3. So I want to rotate by multiples of pi over 3. And depending on what version of GeoGebra you work in, this can get a little complicated in the input bar. So I'm going to type it in Notepad and then copy paste, also because we can reuse this code again and again. So what I want to do is define a sequence. So I'm going to type sequence, open parentheses. So I'm telling it I want a sequence of things. So then next I tell it what things I want to have a sequence of. So I want a sequence of rotations. So I'm going to rotate. Well, we already know how to define a rotation. We tell it what we want to rotate, how much we want to rotate by, and what we want to rotate about. Well, let me go in here and see what the name of my polygon is. So this is the polygon I want to rotate by. It's poly 2 prime. Well, if you're not sure quite how to type that, you can always see in the basic properties tab the name of that thing. And if you want, you can just copy, paste it over into your sequence. So I want to rotate poly 2 prime by multiples of pi over 3. So what I'm going to do is I'm going to write pi times I over 3, and I'll explain the I in a second. So I'm going to rotate by multiples of pi over 3 about, and then what is my point? My point is H. So I'm going to rotate about point H. So I'm rotating this thing by this much about this point, and then I close those parentheses. So that defines my rotate function. But my sequence needs a little bit more information. So I want a sequence of things, and this I in here is what we call an index variable. And that's just a placeholder for my sequence. So I need to tell my sequence what the first value of I want to be, and what the last value of I want to be. And first, I'm going to put a comma here, and I tell it that I is my index variable. And is going to vary. We could do it from 1 to 6. I like to do from 0 to 5 so that my original one isn't a rotation at all. It's just my starting point. And then I want to close my parentheses. So basically, I'm first going to rotate my object by pi times 0 over 3, then by pi times 1 over 3, then by pi times 2 over 3, all the way up until I rotate by pi times 5 over 3. And I will copy and paste this into the chat in case anyone needs that. So I'm going to copy and paste this over here into my input, hit enter, and now I've got a lovely little, oh, whoops, I accidentally sent that not to everyone. Try that again. There we go. So hopefully now we have a lovely little group of stars that move when we move our slider. So I'm going to paste that over here. And, ooh, that didn't work because my variables here are different. So let me go and find my sequence. Oh, I've got so many things going on over here. Let me hide some stuff. Segments. Sequence, there we go. I'm going to delete that sequence. Whoa. I don't know what just happened to my GeoGebra. When I get GeoGebra, it doesn't open again even after I restarted my computer. Does it have bugs? It should open again. I'm not sure why it wouldn't open again. And I don't know to what extent the software has bugs. I know that it's very finicky, and if you don't have a fast computer, it can very quickly get bogged down. But it should open again. So I don't quite have an answer for you there. Yeah, sorry. You can always try the browser version if the standalone app doesn't work for you. All right, so let me see what I need to change in my code. So it's still called poly2 prime, but this time I need to rotate about I. So let me edit that. Rotating about H was not working here. Scroll down to my input bar. There we go. That's what we want. And then sort of beyond this, like if you want to build your pattern out any further, basically you'll just have to construct more lines to reflect over. So for example, I can construct another line that connects these 2 points because I know that my next like star would live out here, and I could reflect a star over that point. Or even better is let's reflect a whole list. So I'm going to use my perpendicular line tool, and I'm going to construct a line through this little point right here that's perpendicular to that line. So perpendicular line tool, select a point, then a line. And I'm going to click on my whole darn list, and then that line. Whoops, actually, I need to select my Reflect About Line tool first. And then I'm going to click on the list, and then the line. And then we can make a sequence of rotations of the list, and you can just kind of keep going from there. So what I'm going to do is this list has a name. It's probably like L1 prime. Yeah. So it's like prime is pretty standard math notation for an image of something. So L1 prime. So I'm going to go back here to my saved stuff, and I'm going to copy paste this, but I'm going to change poly 2 prime to L1 prime. And now I'm going to paste that into my input bar. And that generates it even further. We can see that misses that center star, so we would have to reflect it and do some more rotations. But that's the basic idea. At this point, I would hide my points. So I'm gonna click on the word point, and over here, I'm going to click Show Object, so to hide those. Over here in Classic 5, I can right-click on the word point and Show Object. We can hide our lines the same way. So I can go over here, Show Object. But if I wanted, say, to be able to fill in those stars, we'll probably want to fill in those stars. We've got time. Let's make sure we're showing those lines. And I want to reflect my star. Where do I want it? So I need it to live here, and I also need it to live here because I want to rotate it around here and here. So let's do, oh, I need a point. So I need to show my points again. Let me show those. So I'm going to construct a vertical line here. Oh, awesome. Good. Yeah, so one nice thing about GeoGebra 6 is that if you have a GeoGebra account on geogebra.org, everything you save here saves in the cloud. So you can open multiple places, easily share your files. It's portable, all that good stuff. So I'm going to reflect this first star over here, and it's going to be like the same idea. So I need to have a line that represents the mirror I'm going to reflect over. So to get this star here, I reflected over this line that was a line segment. If I want to reflect this star here, I need a vertical line here. So I'm going to do that with my perpendicular line tool. And I'm going to click on the point and the line I want to be perpendicular to. And I'm going to use the Reflect About Line tool. I'm going to click on the thing I want to reflect. So I'm going to zoom in a little bit so I can more easily select it. So I'm clicking on my polygon, and then I'm clicking on my line. And then I want to do the rotation again, and I'm going to just copy paste that same code, except I want to make sure I have the name of this new star. Oh, come on. Nope, I don't want the points. Let me zoom in. Okay, so this is poly2 prime sub 1, which, you know, who would know to type that like that unless you use GeoGebra a lot? So I'm going to copy and paste that in here. Now, obviously yours might have a different name, so make sure you pay attention to what your things are named. And I'm going to copy paste this code into my input bar. And that gets me that layer of stars. And then to get the next layer of stars, I want to reflect about this line. So this polygon reflected over that line. And I'll show this again in the other GeoGebra. This polygon is called something, poly2 prime sub 2. Well, same thing, but with a 2. So I'm going to copy and paste. And that fills in more stars. So we're generating a bunch of stars now. So now I'm going to go back and hide my points like I had before. Oh man, I have so much scrolling in this version of GeoGebra. So hiding my points, hiding my lines, and I also want to hide some of these polygons that I don't need anymore. And I can also hide, is it this list? Yeah, so I can hide the list that I rotated to get the other lists. And I don't think I ever saved this file. So we're going to save this one as something. All right, so let me show you how we do that over here. Let me show my points. So I reflected this polygon over this line segment to get this one. I did my sequence of rotations, but this time we're rotating about a point whose name is H. I just need, you know, a few more things. Oh, I could actually also reflect about point here because I have rotational symmetry. So that's like sort of a little quick and dirty way of doing that. L1 prime, what was this, H. So I'm going to replace this with L1 prime. Copy paste that into my input bar. And I need a star over here. I'm going to do reflect about point again because I have a point. This is poly2 prime sub 1. Put that here. Copy paste. And then one more. You can't always reflect about a point, but when it's perfectly symmetrical left and right, you can. And again, this is poly 2 prime sub 2. So I can just change that to 2 and copy paste. And that generates the whole thing. And we can hide our points. I always recommend hiding points before messing with the animations because it can get really clunky with lots and lots of points visible. And I'm right clicking on my segments and hiding the labels in Classic 5 because they by default they show. So we've got our construction, does all kinds of cool stuff. And I would say, like, if some of the sequence stuff is a little confusing, I highly recommend working through some of my tutorials on my Patreon. I go through some of this stuff and have a bunch of like written out step-by-step instructions for those things. I will go back and I'll write up an algorithm. I have sort of a rough algorithm for this. The problem with writing step-by-step instructions for something like this is just that everybody's variables are going to have different names. And so if I tell you, oh, reflect point A about line GH, well, if your point isn't called A or your line isn't called line GH, you're going to end up with a different result. So I have sort of a rough algorithm, and I'm going to share this PDF on the Eventbrite page and also on my Patreon. But I have a number of YouTube videos and that sort of thing where I use a lot of these same tools. So I highly recommend going through those. Again, I'm gonna have more classes. You know, but for now, what questions do you have? Are there any steps that I need to go through? Or are there things that you're asking yourself, why did we do that, or why does that work? Did anybody get to this?
Hey, Sarah, no questions for me. It worked really well for me. I'm
Yay!
very impressed.
Awesome. I'm so glad. It doesn't always work the first time. And I hope that if yours didn't work the first time, that you're not getting frustrated. Definitely my GeoGebra constructions don't always work out. I define things wrong all the time. Those don't make it. Well, sometimes they do accidentally make it to Instagram, and I'm like, ooh, I did that wrong, and then I delete it, and then I'll post the right thing. But like it's okay. Well, I think one of the hardest things when you're learning is figuring out what you did wrong if something didn't go right. And that's where I would say like you can really benefit from like a one-on-one tutoring session, which I certainly am more than happy to do, where you can share your screen and I can look at your code and we can figure out wherein your mistakes lie. But we've got a little bit of time, so if anybody has any questions of like, mine is doing this, why is it doing this, and can you help? And you don't mind sharing your screen for the class, we can certainly troubleshoot.
I have a question that might be a little unrelated, but I've been wondering, is there a way to change the default line widths and colors of GeoGebra 5?
Yes. So in your properties, um, you've got some different options, right? So you've got your properties for your specific object, you've got your general graphics properties, you've got some layout properties, and then you've got default
Okay.
properties. And it's in those default properties where you can select like, I mean, you can have kind of all points do a certain thing, or you can have some of your points do a certain thing. But like if I want, say, to have a default line width, I click on line and then I can select how thick I want that all future lines to be.
Yeah, so I know that this would work for, yeah, like future um, elements, but
Like how
when I
can you go
close
back and
GeoGebra and
change
open
all
it
of
back
them?
up, it goes back to the old settings. Is there a way for it to be
Oh, how to
permanent?
save your defaults?
Yeah.
Um, Hmm, that's a good question. Um, Probably I'll look into it and get back to you. I don't really pay too much attention to like what my line thicknesses and all those sorts of things are. Um, Initially, like I just kind of go with the GeoGebra defaults and then manipulate my lists at the end. Um, because like somehow I can just click on list and then go to my objects, make them all transparent and black and thick, and then I can export, as whatever I want it to be. And it's like it's like it's not that hard to
Yeah, when you
do
have these
things.
lists, it is much easier than the mess of elements that I've had in the past. So
Yeah.
maybe it's a non-issue now.
And I like I'm constantly changing thicknesses of things as I go. Like, I kind of like things that I'm working with at the time to be a little thicker. And then occasionally, like, okay, I'll select all my lines that I've already used and make them all really thin so that they sort of fade to the background, but they're still there. And then, but my new lines are thicker. So I don't know. It's but I'm pretty sure there's a way to save your defaults. I wonder. Um,
Maybe save settings. I didn't see that before.
oh, yeah, there you go. Save settings.
I might do it.
Yeah, I bet that would do it.
Another question. So with the slider,
Yeah.
um, these animations that this is able to do, I'm wondering, is this just limited to inside GeoGebra? Do you have any thoughts on how you might like export just being able to make this animation and like um After Effects or other software?
I mean, so you can always you could capture an animation and then edit it in like video editing software if that's what
Okay,
you're
do like
asking.
a screen capture.
Yeah, so I'm a Windows user, so I always just hit Windows G and use the like the internal thing that's meant for recording your video game gameplay, but I use it to capture my GeoGebra stuff. Um, like, woo, there it is. I can capture whatever.
Hmm.
Um, but yeah, so you can always do screen captures. I very frequently will export these and pull them into Adobe Illustrator right? Like GeoGebra line thicknesses are very fixed, right? Like it can only get so thick, or and so I'll pull it into Adobe Illustrator and change my line thickness or add a drop shadow or this, that, and the other. And then I always end up pulling my Illustrator into Photoshop and manipulating it there too, and
Yeah,
all
that's been my
kinds of
process.
things. So, um, and then, but some, like I've also taken these, pulled them into Illustrator, used the new 3D extrude in Illustrator, and then export it as an object file and 3D print some stuff. So there's a lot of options. You can even construct like um, 3D stuff um, in GeoGebra. Hang on, I can't see this very well because of. Let me close my preferences. Oops. Like right now, this is just like a flat thing, but I can construct 3D stuff. Um, and this is, I would say, one thing that GeoGebra 6 can do that GeoGebra 5 can't do, is the exporting of 3D objects in a useful form for 3D printing and stuff. If you're trying to do that, like you're constructing patterns on a sphere or something, I would use GeoGebra 6 for sure, which I've only played around with a very little bit, just because it's a lot more complicated to construct a pattern on a sphere than it is to construct a pattern in the plane.
Sure.
But yeah. Any other questions, comments?
I had a question about the oh, sorry.
Go ahead, Nick.
Sure. Oh, thank you. I just wanted, a question about sort of, you did the sequence to kind of rotate around the point, but I was wondering obviously with a hexagon, you know that it's essentially sort of a grid with an offset, and you could, if you wanted to do lots of, like a much sort of, without having to do the sort of circles and circles to keep reflecting, is there a way of creating a sequence that would essentially sort of translate it down a line and potentially do that in 2 directions? I don't know if that might be.
So translations are really just like sequences of reflections. So GeoGebra can do a translation in terms of like reflections, but the issue is the iterations, and you have to be able to define it in terms of something. So like if I were if I wanted to translate, this object 6 times in this direction, right? I have to be able to tell it by how much I want to copy it, or like what I'm reflecting over. So like if I had a sequence of lines that I were reflecting over, I could make a sequence that way. Or if I had all of my objects like defined to be a particular size, then I could say, okay, translate by 2 units or 2i units or that sort of thing. I would say the hardest part there is like when you're dealing with irrational numbers, because your iterations can only be like integer iterations of things. I find that it's easiest to make these like lists of lists where you're like building a smaller unit, then you're building a bigger fundamental unit, and then you're building a bigger fundamental unit, so that when you are doing those rotations, you're not having to like rotate as many things.
Yeah, that makes sense. So you kind of just creating exponentially more things.
Yeah.
Because you're changing the object that you're working with. That makes a lot of sense.
Simon, did you have a question?
A comment and then a question really. The comment was because I'm an engineer, I like to work in 30-degree angles because I can see that it
Sure.
fits. So I was working that way and I've managed to do it. When I was doing the repeat the sequence, it depends on what you're reflecting. So if you reflect something which has already been a reflection, as a set of 6, it won't create the single item, it will create the reflection of everything.
Correct.
So what I was looking to do was to always find a reflecting line from the central polygon, because I know I'm only reflecting 1, and then I can do a sequence of 1 around, sequence of 6 around.
Right.
So I've managed to get to 4 polygons going out from the center as a wider hexagon. Yeah, really happy with that. Really enjoyed it. Thank you. Thanks.
Nice. Awesome. You're welcome.
Another abstract question. Is there a way
Yeah.
to define a collection of objects so that you're not sort of doing the middles of the hexagons and the outside, or?
Unfortunately, no.
Damn.
You can't group.
It's a shame.
You can't group the objects. Now, if say you had this and then you pulled it into Adobe Illustrator, you can group objects that way. And you can do, you know, some of those reflection and rotate things in Illustrator too. They're just not as mathematically precise, so I don't like to do my reflections and rotations and stuff in Illustrator, but you can definitely group objects. Like, so I'll join line segments in certain ways in Illustrator so that, you know, I can make certain things one color or certain things one line thickness. So, unfortunately, you can't just group the objects. You got to rotate each thing. Now, you know, the nice thing about a lot of these patterns is that they're mathematically too colorable, and so I don't have to construct like we didn't construct any of the hexagons, right? We only constructed the stars and the hexagons appeared. So, you know, you can get away with constructing more minimal things than you often think you need. Unless, say, you wanted to color them inside GeoGebra, right? Like, I can make all these guys like have a certain color. Where did my properties go? Come back. Oh, I lost my properties. Where did you go? Wow, love that. Well, usually it just pops up. I don't know what happened. But anyway, so let's say I want to change.
You have your preferences in the middle, right?
Hmm?
You have a window in the middle of your screen. What is that?
Oh, it was totally hiding behind. I had you guys hiding it. Yeah, no, that's exactly what it was, and I didn't see it because I saw you guys. But yeah, there it is. It was hiding. But yeah, you know, I can give those a fill or whatever. I usually will do my coloring in Photoshop and Illustrator typically, just because it's a little bit easier, right? Like this poor little polygon in the middle got left out, and I would have to do him separately.
Sarah, can I just confirm, when you select the list, it selects all of the polygons and all of the segments so that you can color everything?
Correct.
Okay, rather than having to do it. Yeah, okay, great. Rather than having to select all of the segments to change their color.
Yeah, so like when I select this polygon, I don't have to just select this one little line segment and change it. I can select the whole polygon, and when I change the color, you know, it changes the color.
Okay.
So same thing if I'm selecting a list of polygons, it's changing all the line segments and all the interiors of every polygon in that list.
Thank you.
Now, if I have lists that are representing more than just polygons, so I'll often do what are called polylines, where it's just the outline of a shape and doesn't have an interior, or it's just like not a closed line, but like an open line shape. And if I have lists that represent something that doesn't have an interior and some things that have an interior, if I try to select all my lists, I won't have the option to change the opacity because some of the things that I'm selecting can't do that. So in that case, like, you know, you would have to just select the ones that do.
Great, thank you.
You're welcome.
Hi, Sarah. I'm still stuck at the first star. I was wondering, I have two requests if you would be kind enough to answer that. If you can guide me how to reflect the first star over 6 times without the sequence, the mathematical sequence.
Sure. So just to do it simply without the sequence? Yeah, absolutely. Are you using 5 or 6?
6.
Okay, so we'll do it in 6. So I can do this like super quick. Let's see. Let me show my algebra. So let me do my point 0, 0, my point B 1, 0.
I mean, after you complete the first star, how do you reflect it?
Yeah, so, well, okay, let me, I'll have to delete, I can open my thing and then delete a bunch of stuff, which is fine. Let's see. No, that's fine. All right, so let me, I'm gonna delete all those guys.
Excellent.
And so we're here, but we have our points. We have our lines. Actually, let me hide these lines really quickly. And I'm going to right click and drag and delete all these points that I don't have yet, right? All right, what else do I have? Got my hexagon. Okay, so we're here. So then what we can do is we can just use our reflect about line tool. I can click on my hexagon. I can reflect over either the line segment CD, or if I have a line drawn there, I can click on the line, but either of those two things will get it there. And then if I want to reflect this guy around without using the code, I can just click on this star polygon and then click on the lines that pass through the center here. So I can click on this and reflect over subsequent lines. And so that'll certainly fill the pattern up. But it does generate a lot of points, and those are what slows GeoGebra down a lot. So definitely it's sort of easier at first to construct things that way, but your computer might hate you.
Okay, Sarah, thank you so much. Now, how do you export that to Illustrator?
So you've got a couple of options, just depending on what kind of file types you like using. So I will get it to the point where it looks how I want it to look. So I'll hide all my points, I'll hide all my lines, I'll make all of my polygons 0 opacity, make sure all the outlines are 100% opaque and all, whatever, those sorts of settings. And then whenever I'm ready to export it, in my little hamburger menu, I click download as, and I've got all kinds of options. So I can do an SVG, or Illustrator can also work with a PDF. I would say those are probably your two best bets to work with in Illustrator, or SVGs or PDFs. And then, if you had something 3D, you can export it as a STL to import it on your 3D printer. All kinds of options.
Okay, great, Sarah. Thank you so much. I have one last question.
Yeah.
You have a specific dimension that you want to work with. Let's say you're building a wooden, like rectangular artwork, or that you want to put your pattern on. If you have a specific dimension, width and height, how can you start your GeoGebra file?
So being mathematical software, GeoGebra isn't unit sensitive. But when you export, so let's say, for example, I want to export as a PNG. Let's see, this didn't give me the same options that GeoGebra 5 does. Let's see. So I know, like, in GeoGebra 5, if I export, it gives me this option where I can change my scale to, like, where 1 unit is a certain number of centimeters. I'd have to play around with it to see where that is in GeoGebra 6. Let's see. I wonder. Yeah, it's really just doing. That's my axis scale. I would have to get back to you on that on GeoGebra 6. I'm not sure where the export scale properties are, but if you're using Illustrator, you can always change the scale in Illustrator as well, like for your final thing, if you know what the final dimensions are. Because I feel like usually the final dimensions are what you know, as opposed to necessarily like the starting unit for those 2 points you're using to generate your file.
Okay, Sarah, thank you so much. Is there a place you can download GeoGebra 5, or it's not?
Yeah, so if you go to geogebra.org, I guess it helps if I type it correctly. And then click on app downloads. You can see Classic 6 or Classic 5. And Classic 5, you can download here.
Thank you so much.
You're welcome. So you'll notice, right, that Classic 5 is the only one that doesn't say start. Classic 6 is like the equivalent of the web-based, browser-based version. You can't use Classic 5 in the browser. All right. Well, that's 11 o'clock. My family needs me, so I'm going to wrap things up. I will post a link to the recording on the Eventbrite page and on my Patreon as soon as I've got it exported and uploaded. Thank you all so much, and I'll announce whenever I'm doing the next one. It's probably going to be the first Saturday in February. I might kind of try to do first Saturday of the month sort of thing to keep it regular. But yeah, thank you so much for coming. I appreciate you. And if you have any questions, holler at me on Instagram or wherever, and I'm more than happy to take a look at whatever you got going on.
Thanks
right.
again, Sarah. This is really
Oh,
great.
You're welcome.
Thank you,
Thank you.
Sarah.
Thank you very
That was
much, Sarah.
wonderful.
Awesome. Thank you.
See you soon. Bye.
Bye.
Great to see you all.
everybody.
Thank you very much. It was really good.
Saturday.
Bye.
See you.
Bye. Thank you.
Bye.